Hello, my fellow mathletes. I hope you're all feeling fantastic and you're doing well. In this video, we're looking at question number 4 on our Canadian Senior Math Contest. How many 5-digit positive integers can be formed by arranging the digits 1, 1, 2, 3, 4 so that the two ones are not next to each other? Okay. So it's going to be a counting problem. Now, when we arrange our numbers, the two ones are going to make things a little difficult for us. If it was just 1, 2, 3, 4, and 5, and I imagine a 5-digit number, I've got 5 choices for what number to pick from these 5 for my first digit. Suppose we use 3. Then I've got 4 choices of the remaining digits to place here, and then 3 once that's chosen, 2 and 1. And this gets us something called 5 factorial, which you can 5 times 4 times 3. It's 120. Okay? And this works if all 5 numbers are different. But we don't have all 4 numbers or all 5 numbers different. We have 1, 1, 2, 3, 4. Okay? So we don't get the full 120 that we would want. Okay. So what can we do? How do we approach this sort of a question? And remember, we care whether or not the ones are beside each other. Okay? So there's a couple approaches you can try. What I would do is I would focus on these ones because the ones are causing me the problems. And as soon as I've got the ones placed, well then I've got 3 choices for the number to go here. Is it going to be a 2, 3, or 4? 2 choices for this number, 1 choice for this number. So as soon as the ones are placed, there's 6 different ways to fill in the remaining numbers. Okay? And it doesn't matter how the ones are placed, as long as they're not touching, they're not side by side, we'll then get 6 ways to place the 2, 3, and 4. So I don't have to list out all the numbers in order to actually be able to get the answer here. But what I do need to do is I need to be able to list out all the different ways the ones can be placed. Count that up, and then multiply it by 6, and we'll be done. Okay? So let's see if we can work out where to place our ones. Now we can have a 1 here, but we can't have a 1 here. But it could go in any 3 of these other spots. Right? So each of these give us 6 different ways to fill in a number. For example, 4, 3, the ones have to be here, but we could have 4, 2, 3. That's a possibility. That's a number that's allowed. Okay. And that about does it for ones that can be placed at the start. So now let's leave the start blank and put a 1 here. My next one can't go here, but it could go in one of these 2 other spots. That gives me 2 more different ways to place the ones. Each of those give me 6 different ways to make these numbers. Okay? And that about does it for ones in the first or second spot. How about in the last spot? Well, the next one can't go here. It's got to go here, and that's about it for that one. And that's 6 more possibilities. Okay? So in total, we've got 6 different ways to place the ones so that they're not side by side. And then we've got 6 for each of them. So we get 6 times 6, 36 such possible arrangements. Now, you might say, all right, that's fine. What if the question were harder? What if we had not 5-digit numbers, but we had 2 ones and maybe 10 different digits because we're working in a different base system? How would we get the number of different ways to place the ones? Okay? So here's something a little more advanced. We are done the question, so if you want to move on to question number 5, go right ahead. But I don't just go through questions. I try and show a little bit of some of the math that you can do with these. So suppose instead of having 5 spots, I've got n spots. I still have 2 ones. Okay. Where can I place these ones? How can I place these ones? Well, if I've got my first one here, there's n minus 1 different places for the next one. So if my first one is in the first spot, n minus 1 different places. If my first one is here, the second one has to be further down. There's going to be n minus 2 of them left. Sort of like when we were placing our first one here, we had 1, 2, 3 spots here, 1, 2 here. Okay, but we do need to be careful. Can all of these n minus 1 work? Well, no, you can't have a number here. So it's not really n minus 1, it's n minus 2. Can't place my second one here because these ones aren't supposed to touch. So this should really be n minus 3. We can update. Okay, and we keep going. Okay. Now, can't have 1 here, but the remaining n minus 4 spots after the 1 and the little gap are fine. And all the way down to a 1 here, nothing here, and a 1 here. Okay. So that's the idea. And so how many? So if my 1 is in the third last spot, there's only one different way. So we have really n minus 2 plus n minus 3 plus n minus 4 plus 2 ways plus all the way down to just 1 way to place that second 1. So this gives me the total number of ways to place 2 1s amongst n different spots so that the 1s aren't together. Okay? Is there a formula for something like this? N minus 2 plus n minus 3 plus n minus 4? Absolutely there is. Okay? In general, if I want to add up the first k natural numbers, this is something that's very useful to know for math contests. The formula is k times k plus 1 over 2. Okay? So what have we got? 1 plus 2 plus all the way up to n minus 3 plus n minus 2. The biggest number here is n minus 2, but we're going up by 1 each time. So it should be n minus 2 times n minus 2 plus 1, which is really n minus 1, all over 2. So that's how many ways to place the 1s so they're not side by side. Does this track with what we just saw? We had 6 different ways to place our 1s when there were n equals 5. 5 minus 2 times 5 minus 1 all over 2 is 3 times 4 over 2, 6. And wouldn't you know it, we had 6 different ways to place the 1s. Okay? And this 6 over here came from the number of ways to place the remaining different digits. That would require work with factorials. Okay? It can all be done. I think I'm probably going to stop the exploration here. I just wanted to sort of show you how to approach the general counting problem if you didn't want to just list out all the different possibilities with 1s. Okay? But it's certainly an interesting question and things that you could ask yourself. What if I had 3 1s and I didn't want any of them side by side? How would we count it then? Okay? What if we had 2 1s, 2 2s, a 3 and a 4? There's fun little variations you can do. Try experiment them out because maybe on next year's contest they'll have something just like it. But as I say, I think that's it for me. I think we're going to move on to question number 5 in the next video. So thank you guys so much for watching. Feel free to like or subscribe the video, and I'll see you for question 5 in part A next time.